Hello everyone, I am Aryandhar from Jammu. I am going to start a YouTube channel generally regarding videos of mathematics, exercise, and maybe some cooking later on. Okay, and I might take some important topics like the first one, which is going to be advanced complex reactions. So, this is the topic advanced complex reactions, right? So, this topic is regarding nuclear decay and radioactivity. And there are generally three type of reaction: parallel reaction, sequential reaction, and reversible reaction. So let me just first start with parallel reaction as it is the most easiest one of them all. So here it is now. So first we are having a radioactive nuclei A, which decomposes into B and C with rate constants with K1 and K2. Initially we are having a amount of A, and let us assume at some point we are left with this amount of A nuclei and X amount of B nuclei and Y amount of C nuclei are formed. As nuclear decays are obviously first order reactions, so R1, that is the rate of the reaction from A to B, is given by rate of change of B, which is equal to K1 into A. K1 is the rate constant and A is the reactant. Similarly, R2 is equal to rate of change of dC by dt, and which is given by K2 into A, concentration of A. And R net here is equal to R1 plus R2, which is also implies using these relations, K effective is equal to K1 plus K2. So which also implies that T effective ki power minus 1 is equal to T effective first of first reaction ki power minus 1 plus T2 ki power minus 2. So this is the first result. Now going on, as K is equal to K1 plus K2, using that want half factor method, we can write it as A e ki power minus activation energy by RT, which is equal to A1 plus EA2. Now we differentiate it with respect to time to get a specific result. On differentiating, A we just cancelled because it is common from all sides, and the coefficient of T also comes down, minus EA by R. So from all sides, cutting and using the relation K is equal to A e ki power minus EA by RT, we get another result regarding equivalent activation energy. That is E net, which is equal to K1 E1 plus K2 E2 upon K1 plus E2, K1 plus K2. So that is the second result. Now just starting with the main reactions. Here we can write R net is equal to K1 plus K2 into A. So R net, which is equal to minus dA, right? Taking A below K1 plus K2, and wait a second. Yes. So here it is. It is dt K1 plus K2 K effective negative of rate of change of A by A. So when we integrate it, we get this result: A is equal to A naught e ki power minus K1 plus K2 into T. And also from the above result, this and this, we get ratio of the concentration of B and C at a particular time is given by the ratio of K1 and K2. So from this we can get the percentage of B and C. Now further going on, dB by dt, which is equal to K1A, and writing the value of A, then also integrating this function from 0 to 2, 0 to B, just basic integration, we get the concentration of B, and similarly C. So just this much is regarding parallel reaction. It is very easy, and here the topic is complete. So from here it starts advanced complex reaction. So this topic is complete. Now for the next topic, that is reversible reaction. So it is a bit complicated than the first part. So let's just start with it. Here it is. Here A is getting converted into B and B is also getting converted into A. So the rate constant of the forward reaction is Kf and backward is Kb. So initially we have A moles of A and 0 moles of B, At a time t we have x a minus x moles of a and x moles of b, and at equilibrium we have ax minus x equilibrium and x equilibrium moles of b. So we're just writing the basically rate of change of x, which is equal to negative of the rate of degradation of a. So which is equal to k forward into a. Here k forward is from going to a to b, and we write the reactant with it, and minus k backward into b. So we just have to integrate this. Before that, we let us see that at equilibrium rate of forward and rate of backward is same. So dA by dt and dB by dt are zero because they are not getting converted. They are getting converted, but the rate of conversion is not changing. So from this and using this result, we get kb by kf is equal to this. Now putting this into this, we get this result. Now it is just basic integration or like that, k forward a like this. So we just have to basically integrate this. Integrating, after getting x, we put the value of x, we get b. Similarly we get c, and we can see that this value here is actually x equilibrium, and so we get x is equal to x equilibrium into this. From this we get this result. Generally, even in advance, only question related to this result are asked, so that much would be sufficient, and this topic is also completed. Now just a simple question regarding this topic. We are given that initially, and we are given a question in which N1A is converted into N2B. It is first order with respect to initial moles of A is A, and finding volume at a time t. You can try this question. If you are not able to solve, probably, then you should see the solution, which I am going to show you now. So solution first, like the basic, always we do this. A minus n1x, which is converted into n2x, and here 1 by n1, this is important. dA by dt is equal to ka, but here minus 1 by n1, this coefficient is also important. When we integrate this, we get the value of at as a function of time, which is equal to a minus n1x from here. So we get x, right? So going forward, we get B, concentration of B, moles of B at a time. And here we are not given anything about pressure and temperature, so we'll be taking those as constant, and we can say that volume is directly proportional to moles, so the ratios are equal. So we get finally this as the answer. This is a maximum level. Generally, even in advance, the level of questions which can be asked. So going to the next topic. Now the next topic is sequential reaction. For this, derivation of this, not only you require the knowledge of integral calculus, but also differential calculus. Differential in the sense differential equations. Sorry. So for this sequential reaction, A is converted into B, which is also getting converted into C, and the first reaction has a rate constant K1 and the second has a rate constant K2. Initially, A moles of A are there and 0, 0 of B and C. So at some time a minus x, y and z, and y and z are not same, that depends on the k1 and k2. So basically we get the simple results like these. Negative of rate of change of a is equal to k1a, negative rate of change of c is equal to k2b, rate of change of b is equal to k1a minus k2b. These are like the previous results which we have done in the previous question. Now basically this one is the most simple, which we have always been doing. For B it is little bit different. So arranging it, taking k2b to other side, we get this equation. This is just a linear differential equation. It's actually very simple. So whatever is the coefficient of B, right, dB by dt, to B, whatever is the coefficient of B, we first find an integrating factor, e की power integration of the coefficient with respect to time. We multiply it with b, which is equal to, this side we also multiply it by integration factor, and we then integrate. So after integrating basic integration, we get the value of b as this much. Similarly, using c, we can do the same integration, basic integral calculus, we get the desired results. So this one topic is almost complete. So taking it from above. So just please turn over. Some part of sequential reaction is still left, matlab just a basic result. So at any time we can see the concentration, some of the concentration of A, B and C are equal. This is just an extension of the conservation of mole result, as volume is constant. So this initially B0 and C0 are the concentration of B0 and C0, which are 0. So there are some just graphs like these. You can just not actually that much useful. So going to the next topic. So this is a case when the B is maximum, concentration of B is maximum. So not concentration, moles. At that time the rate of change of B is equal to 0 at maximum. So K1A is equal to K2B. Regarding using the values A and B, so we get this equation. Then we get T, value of T when B is maximum. We get concentration of B by putting in the result, and we get concentration of C by using this concentration conservation formula. So this is just a result. So this advanced complex reaction topic is complete, but I have a bonus topic which is kind of above the advanced level. Not questions are asked regarding this topic, but still just for knowledge and by chance. So this is the topic of Maxwell distribution. Maxwell distribution of speeds. So according to this law, what is actually given? The probability of the molecules moving with the speed c plus dc. In this range, the probability of molecules, it is given by PC, probability, favorable cases by total cases, and this is just a basic equation, right? And so when we differentiate it, we equate it to 0. Yes. So and we equate it to 0, we get the value of most probable speed. We do not need to double differentiate to check maxima or minima, because obviously the minima is 0, so the value we'll get is the most probable speed. You understand now? For V average, we just have to do a little bit of integration. The differentiation part I left for curiosity, because differentiation is very easy compared to integration, as everyone can do differentiation. So integration, you require a little bit help. So for V average, we have speed. A speed of molecules can be from 0 to infinity. So we just have to apply the basic integration result. This is the basic result. You might have seen it in physics, maximum in kinematics. So C average integration C dn by integration dn. Here we can't actually put the value of C, because there is no actually here C square in this result. So what we do is put the value of dn. When we put the value of dn, most of it is just constant, and for this result there is just a basic result. Integration 0 to infinity c cube e power minus bc square dc is equal to this. Putting the value, we get C average. It's actually very easy. These are just basic results. You can also try it by parts or by using some beta gamma function, this type of thing. Now going on VRMS. So for this, it is just the root of mean of square of speed. So C square dn integration by all particle average ka root. So similarly, we have to use just this result, and by using the result, we will get CRMS is equal to 3 kT by m, right? So I think you might have learned some stuff from this video. And if only you like the video, then like, share and subscribe to this channel. Also, I write the things beforehand making the video, as to make the video more effective and to prevent the time waste of people who are watching this. And these are the only two topics which I'll be taking. Otherwise, it's just going to be mostly mathematical questions and maybe some other topics later on. And also, there's no, due to COVID lockdown, I am unable to get a whiteboard or marker, so I'm just going with the pen and paper stuff. So this is just the overview of the notes. which I made just now before this video. So thank you very much.